All right, so notice yesterday was 6.1 and today 6.3. Oh, we skipped 6.2. Cool. So once again, note if you are not a senior and you are trying to petition from Trig to get into pre-cal instead, you should probably go through and look at what 6.2 was. This is one of the things that I skip and Algebra 2 does not. So 6.3 is a square root function. Have you seen a square root function before? Yeah? What does it look like? On the count of 3. Oh no, dos, tres. Hey, it's kind of like you're at the movie theater. Yeah? You like slip your arm. Yeah? You get it? Okay. You'll never forget it now. You're welcome. There you go. A little memory. So you're at a movie theater and you slip your arm around someone. It's kind of like how it's that like, what shape? I don't know. Is there a way to describe this in English that makes sense? It's kind of like a hill, but you don't go down. You just like come around their shoulder. All right, so imagine. Hold on, I gotta make it better. Let's see. Here's Tall. He has this like black hat on. Okay, and then I gotta draw Dylan. Here's Dylan. Yay! And he has like a hood. So here's this like hoodie, whatever. Okay, hoodie. Okay, there you go. Hoodie. And then ready? Here's Tall slipping his arm behind. Hey, it's like a square root. Or let's do it the other way. Right? Here's Dylan slipping his arm around. That's roughly what a square root function looks like. You start and it curves up but slows down. Curves up and then like it keeps going up at a slower and slower rate. Right? So if you have someone next to you, you can like tell them don't do this if you're like don't want personal space invaded. But just everyone put your right arm and just slip it to the person next to you, right? Like put your arm around them. Hey, okay. Perfect. Okay, so we've talked about it. You did it with your arm. Now we can actually draw it. I'm trying to make this like not so much memorization, but like intuition, like you understand what it looks like roughly, right? So if you try to draw a square root function and it looks like this, what are you doing? Your arm doesn't go like this, you know? Yeah. Okay. Yeah. Okay, so the square root of a variable. Square root is the second root. Okay, so saying square root of x is the same thing as saying the second root of x, except we don't write 2, right? Anytime you see a square root, we just assume it's 2. The only times we have radicals that have numbers if it's more than a square root, a cube root. But we're just doing square. So for instance, the square root of 25, do we know what that is? 5, right? Because the square root is always what times itself is the number inside. Okay, so we're going to learn how to graph square root functions. So the parent square root function is literally just square root of x. We're going to make a table of values to graph the parent function. So secretly, I've been like trying to prep you. Remember back in like chapter 2, we learned all about transformations of functions, up, down, flipping. Yeah? It's okay if you say no, because we're going to review it again. So the square root function. Can I put any number under the square root?
No.
No, I can't. What numbers can I not put under?
1.
Louder. Negatives. What happens if you take square root of a negative number? It's imaginary. Exactly. So we can't put numbers under a square root, can't be negative. Okay. So we'll make a table of values, and let's think of some nice numbers to graph. So for instance, Tal was saying 2. Okay, well you can put 2 under square root, but 2 is not a perfect square, so it would give us like 1.414. Like what? No, I don't want to graph that. I want nice integer numbers. So let's start with, we can't have negative numbers, but what's the smallest number we can put under a root? 0. Okay, what is the square root of 0?
0.
Okay, what's the next good number we can put under? 1. Okay, 1. You said that before, but I was looking for 0. What is the square root of 1? 1. Okay, now here's the trick part. Do you want to put 2 under there? Because there's like really 4 or 5 specific coordinates that we always plug in, because we want to graph nice integer numbers, not decimals. Do I want to put 2? Square root of 2? No. 3? 4. What is the square root of 4?
2.
Okay. Do we sense a pattern? The only numbers we're choosing are perfect squares. Oh my God, yes. Perfect squares. That's right. Perfect squares. What's the next perfect square?
9.
9. Oh my gosh. What's the square root of 9?
3.
3. Okay, so we have a couple points we can graph. So I have a dot at 0, 0, a dot at 1, 1. I go over to 4 and up 2, and I go over to 9 and up 3.
So can you just always pick like your points?
These are always the points we're going to be using. Remember when we did quadratic and we always pick the numbers around the vertex? Right, the x squared, we always pick numbers around the vertex. Here, you always want to pick these numbers, and then, you know, if my square root function is being shifted over left or right, then we can just move all of our numbers just left or right. It's these exact things, these exact points. So notice how my graph kind of looks like when Dylan or Tala was like putting their arms around each other, right? Just swooping over, little swoopy swoop. Okay. All right.
It's inversed on the next one because it's negative. Oh no, it's not negative. I didn't. Sorry, it's an equal sign.
Yeah. All right. Do we have questions over this one? Are we good? So this is the parent function. This is what we're going to start with every time. Now, question with example 1a, how is this graph transformed, right? So from just x squared, don't say it out loud, don't point yet, right? Think in your head. How is square root of x plus 2 different than just square root of 2? What's happening? So on the count of 3, you're going to use your fingers and you're going to show me which direction. 1, 2, 3. Shifts to the left. How do you know it's to the left? It says plus 2.
Positive.
It says plus 2. Ah. Inside is opposite. Inside the square root. Inside absolute value. Inside the square, right? It's always opposite. So if it's inside the root, it's opposite. So we're going to left by 2. Cool. Okay. So, what? Left by 2? If it's inside our square root, or remember if it's inside the absolute value sign, or when we had like x plus 2 squared trying to graph this, if it's inside like the square or the square root or the absolute value, it's left or right, versus if I had absolute value of x plus 2, x squared plus 2, square root of x plus 2. If it's outside, it's vertical. Inside it is horizontal. Yeah, remember this? Yeah. Okay, this is why I say it the same way every time. That way it really ingrains in your brain. So, cool, if everything's left by 2, so if this is what my graph looks like, all I do is shift it left by 2. It's the same points. I just shift it left by 2. So, let's write out our coordinates. So originally I had a point at 0, 0, 1, 1, 4, 2, and 9, 3. Right, those were my original points. We just found those up above. Now,
So that's always going to be used for like every.
this is what we're going to start with. These are parent function. And we just said, how is this different than the parent? Left by 2. So what do all of my x values, what happens to all my x values? Yeah, I go left by 2, so I subtract 2, right? I just subtract 2 from all of my values. Because everything is being left by 2. So now my new points I'm going to graph negative 2, 0, negative 1, 1, 2, 2, and 7, 3. That's it. And now we just plot those points. So I want you to compare this graph to the one we did up above. Literally, all we did was take the whole graph and just scoot it to the left. That's it. So trying to show you the table, like you start with those values and then we can move them around, shift them around. So this is like literally today's whole lesson is just graphing the absolute value. I'm sorry, yes, square root. Just square root. So you do have to have graph paper. So that's something I wrote on your lesson plan, is if it says to graph, and hinty hint, you're gonna have to graph some, they must be on graph paper. Okay. All right, so before we go on, what is the domain of this function? Remember, domain is x, range is y.
-2.
Wait, you don't drop the new one.
What? So this is the one I graphed right here. The black was my parent function, the ones from my original just square root, and then the purple is, ooh, I shifted everything, and now that's why I graph. So domain is the x. Is my domain all real numbers? Any x I can plug in? Well, how about if I plug in x equals -10? What's my y value? If I plug in -10 for x, what's my y value? Oh, let's see. Let's see. Plug in -10. What is -10 plus 2? -10 plus 2 is -8.
Oh, I'm sorry.
Wait, square root of a negative number. Oh, it's imaginary. No, okay. I want the domain of the real numbers. So, where am I defined? From -2. Where do I start? Where's my graph start? -2, and then goes on forever. So x has to be greater than or equal to -2. Because what happens if I put in an x value that's less than -2? It's imaginary. You can't put a negative number under a radical. Under a square root, yes.
I thought the graph, you said it was going to go the other way.
No, we shift it left by 2. It's the same way, right? It's the same direction. I just shift it by 2 to the left. That's it.
Wait,
on
you
Y.
can't go the other way because of being negative.
What?
Since you're putting the negative under the graph, you can't go.
If I try to put any numbers, any of these x values, notice they're not defined because it would be imaginary numbers. My graph starts.
What about the 2? If you put a negative under the thing.
Be more specific.
What
I
if
don't know what
it's
you're saying.
-2? Do you see?
Okay, what's -2 plus 2? -2 plus 2? 0. Square root of 0? 0. Define.
No, but what if the 2 wasn't positive? It was negative.
If it was a negative here, that's the next question.
But it's a negative under one of the things.
So
there
you.
can't be a negative underneath the.
Right, and that means that I wouldn't be able to plug in 1 or 2 or 0 because I'm subtracting 2. So my whole graph shifts to the right by 2 if it was a negative under. Here there's a positive under, so I can shift it to the left by 2. Okay, so your question, wait like 5 seconds. I'm literally going to answer in the next problem. Here, I just want to know, what are the x values defined? From -2 to infinity, aka x is greater than or equal to -2. So the domain is x is greater than or equal to -2, because all the x values I can plug in have to be larger than -2, otherwise I'd have a negative under the radical. Now, the range is y. Are we limited?
No.
Yeah, it doesn't even. No.
That's the y-axis.
It touches the y-axis,
Once.
but like the range is the y values. Are there any negative y values? No. All of our values are 0 or greater.
Wait, so I'm so.
All of our y values are looking vertical. All of our y values are either 0 or above 0. So y is greater than or equal to 0.
I looked down for like 1 second when I looked up, I got really confused.
So when I'm talking about my x values, this is where I start, and then all the x values going to the right will be defined. That is what this is saying right here.
How do you know that it's always going to be like the little symbol of the line underneath?
Yes.
Okay.
Yes. For these.
And it's -2 because there's like a +2.
Because this is the smallest number I can plug in where I won't have a negative under my square root. -2 is the value that makes me have square root of 0 when I simplify. Now, as far as y values, right? Notice I have a y value of 0 here, and then all my y values get bigger. There are no y values less than 0. We have a y value of 0 when x is -2. That's why it is greater than or equal to 0. Now, this is just going to it'll just take a couple times of doing it to really understand domain and range. Let's try the next one. So, there's 2 things happening. Think about what's happening. And then you're going to have to use, hint, 2 hands to show me what's going on here, right? Left or right, up or down, right? You gotta show me, but not yet. Think about it. Okay, we'll count to 3.
Jeez.
1, 2, 3, go. So we know it's going up and it's going to the right. Cool. So this makes it go up because it's vertical, up by 1. And then the negative, if it's inside, it's the opposite direction. So -2 means it's going to be going to the right, to the positive by 2. So I'll list out my original parent function values. We always start with these: 0, 0, 1, 1, 4, 2, and 9, 3. These are the original values from up above. Then I want to take every y value, shift it up by 1. So I'm going to be adding 1. And then what am I trying to do with all my x values?
Add 2.
I'm adding 2 because I want them all to be shifted to the right by 2. So to make my life simpler, I'll make a new chart with my new values. What I'm doing is every single point, for instance, I started with 0, 0 right here. Then I want to shift it 1 up and 2 to the right, so this would be my new point. That's what I'm like over here. That's what I'm doing like in a concise way with not a lot of arrows. So if I add 2 to 0, I get 2. 0 plus 1 is 1. And you just go through and do the addition, and I have my new points. Now, compare this, after you're done, compare it to the graph that we started with up above. The original parent function, just square root of x. You'll notice that this graph, we took the whole thing over by 2, up by 1, and it's the same it's the same graph. We just shift it over. Zoom out a little bit so you can see. I'll pause here before I go on because I want to make sure we understand how I'm shifting it and graphing my points. If you're lost now, I want to make sure we answer those questions before I hit the domain of range.
So everything within the,
If it's in the root,
it's x.
it's x. If it's to the right outside, it's y. Mm-hmm. So that's what I was showing. I was trying to show you here, inside versus outside.
So the numbers you start with are 0, 1, 4, 9, and 0, 1, 2, 3.
Yep, because these are the square roots of the x values. Because remember, this is square root of x. And all of this minus 2 and the plus 1 here, all it's doing is just taking our graph over and up, but it's the same graph. Shift it. It's like those old time transparencies people used to have in the 80s. You know, you can move them around. They were old when I was a kid, so don't blame me for not knowing what they are. All right, so are we ready to talk about the domain of range? Okay, so the domain are the x values. I only want to know which x values are plotted here, right? Do I have a y value when x is 0?
Greater than or equal to 2.
Exactly, greater than or equal to 2. Now, the reason how I can figure this out,
Why is it -2?
because -2 is over here, there's no y values. So I see I have a point at 2. Now am I going left or am I going right? Right. So that means all the values to the right are bigger than 2, so it's going to be greater than, right? X is going to be greater than or equal to 2.
Will the graph ever be like this?
It could, yeah, it could flip.
And the next one is greater to or equal.
So look at our y values. Our y values start at 1 and all of them are bigger. So y is greater than or equal to 1. All of our y values are either 1 or they're bigger than 1, above 1.
So is the domain always going to be the opposite of whatever number is when subtracted or added to x within these?
I don't want to say always, but that's a good indication.
Because I've noticed the pattern between this one and the last.
Ah, you're sensing a pattern. Amazing. It might get a little harder.
But it's not always going to be like that?
Yeah. Whatever you
No,
add or subtract
it's-
to y.
It will probably be the numbers, but it may not be always the direction of
Oh,
inequality.
yeah, because the negative.
Oh.
Okay, ready? What does x squared look like? X squared. Parabola, x squared. It's a parabola, it's a u. What about if I say negative x squared? Flips. So ready? What does the square root of x look like? Yeah? I'm waiting for everyone. Sorry, that's like the lamest look I've ever gotten. Like your look says you are so lame and I will not bend to it. Okay, square root of x. What if I have negative times square root of x? It literally flips it. Ready? You take the whole thing. Here, you take the whole thing and you flip it. You take the whole thing and you flip it. You take the whole thing and you flip it. Okay, see, I'm so proud. You guys like did this on your own. Oh my god. Okay, it's so good, so good. Oh my gosh, you guys are doing so well. Okay, let's do it. Let's do it. Okay, so I have 3 times square root of x minus 5. Ooh, tricky trick. What is the 3 outside doing? Don't say it out loud. Think to yourself, what is this 3 in front doing, right? So your options are, shifting it left, right. Is it shifting up or down? Is it causing it to be like compressed, or is it causing it to expand? Is it flipping it? What is this 3 doing? Anyone have a good answer? What is it doing? Compressing or expanding, right? Literally what I'm doing is taking what we just did, right? Oh, okay, this opposite. Expanding, because you're multiplying by 3. Whenever you multiply by 3, it gets bigger, right? It expands it. So this 3 is going to expand it, meaning you used to have absolute value of x. Now it's going to be shift, really make it bigger, bigger, bigger. It's expanding it, making it larger. Okay, and then what about this negative 5 in the middle? What is it doing here? Right by 5, because it's inside the square root and it's opposite the way you think, so we're going to the right by 5. Okay, so I want to make sure I'm being clear when I write out my parent points. Start with my points. 0, 0, 1, 1. Let's see, we start with 4. Square root of 4 is 2. We start with x is 9. Square root of 9 is 3. Okay. So first, I'm going to take everything to the right by 5. If I'm moving to the right, what am I going to do to my x values? Add 5. Add 5. Okay, so I'm going to add 5. Okay, so if I'm expanding by 3, right? So I'm literally taking the square root, multiplying by 3. So which way am I expanding? Horizontally or vertically? Vertically. So what I want to do is multiply everything by 3. Because it's going to be 3 times stretched out. So I'm going to go and multiply them all by 3.
Just the y's?
Just the y's, because I'm not stretching it horizontally. All I'm doing is taking whatever my square root was, multiplying the y values by 3. So it gets expanded.
I'm gonna answer a quiz when you give us a bigger graph and us if we get answers over 10.
No, you just have to you just graph what's on the actual sheet.
So when it's on the outside, like in the front, it's
Yep, multiplication. So I have 5, 0, 6, 3, 9, 6, and 14, 9. So clearly 14, 9 is not going to be on our graph. It's off. It's off. The reason I like putting these graphs is because they are labeled for you. That way everyone's graph looks the same and it's evenly spaced. Okay, so 5, 0, 6, 3, and 9, 6. So it looks something like that, right? It's the square root shape-ish. It's just really stretched out. You take all your y values, multiply by 3, it's stretched out. Right? So it's like curving and swooping. It's just not as it's not as smooth. It's kind of like if you're really, really short and you're trying to put your arm around someone really tall, you got to really stretch to go around their shoulders. That was cute. Okay. Okay. Are we done writing? Think about domain and range. Think about domain and range. Okay, don't say it out loud. I'm going to pick 2 people, and you're going to tell me that. Think about the domain and the range. Remember, domain is x and range is y. All right. Who hasn't talked today? Dylan Benson. What's the domain?
Domain is x is greater than or equal to 5.
Yeah, how did you know it was this? How'd you know?
It's on 5.
It's on x equals 5 and all the values are larger. So all of our x values are either 5 or they are bigger and going to the right. Okay, and then the y, let's go. Ashton, what about the y?
Greater than or equal to 0.
Yeah, y is greater than or equal to 0 because the smallest y value I have is 0. All the y values are greater because they're bigger. How do we feel about this so far? Right? You get it? Like, what the hell's going on? Or like, you know, whatever. How do we feel? 1, 2, 3. Hey. Okay, cool. Okay, we're good. Let's do the next example. It's solid. We've only really done like 3 or 4 examples, and we're getting there.
This one's flipped.
This next, you took it away. It's gonna be like, okay. So, how do you know it's flipped? What?
The negative is outside.
Okay. So think about what do we do first? Are we going to take the square root and add minus 6 first, or are we going to multiply by -1 first? What do we do?
Multiply.
We have to multiply by -1 before we can do -6. Order of operations. Okay, so we see this is going to be going down by 6. What about this middle? What about the middle? What's happening here? Left by 4. Okay, sweet. This is why we spent like 2 days doing transformations, because it's in every chapter, almost every chapter. And like, if you are good at it, you learn it in the first, it makes it much easier for these later chapters. And I'm trying to draw the like pattern for you, so you like see if it's inside the root, inside absolute value, right? That's horizontal. If it's outside of it, to the right, vertical, outside to the right, okay, it's always up or down. But if it's before the root, that's going to be multiplying. And when we multiply by -1, remember, just flips. So normally we have absolute value, and then we'll flip it. Right? I don't know. What's this shape? What is this movement? I don't know.
So why do you?
Like, Scooby-Doo. Okay. Scooby-Doo. Okay, yeah, we're scooping. That's a good one. Scoop. It's kind of like bowling. At the gym the other day, there's these people doing professional bowling.
Where?
At the gym. On the TV. Sorry, at the TV on the gym. At the gym on the TV.
I thought you were talking about here.
No, I quickly changed the channel. It was boring. Okay. Because these people were like, and the first one he did was a gutter ball, and I was like, done. Okay. I can do that. I can do that. Thank you for coming to my TED Talk. I can be a professional bowler. Okay, goodbye. That's okay. Wow.
Yeah. We have this bowl. Oh, this one. Oh.
Okay. I don't mean to be disrespectful against bowlers. It's fun, okay? My grandma bowls. I think that made it worse. Okay. 0, 0. Our other points, remember, we're starting with all our parent points, and then we're just shifting everything, stretching it if we need to. Okay. 1, 1, 4,
Are you adding
2.
a negative to the y's?
So, okay. Let's go step by step. So this first one is left. Oops, let me pick a different color.
So you subtract the 4 from each one.
Yeah, so I'm gonna do the left first. Left first, which is x. So we're subtracting 4 from all our x values because we're going to the left. So that's going that direction by 4. So we have to go 4 to left. So it's the x values. And then, okay, so that's the x. We dealt with that. Now, flipping and then down by 6. So we have to flip by multiplying by -1. Because order of operations, right? If you have negative square root of x minus 6, you have to do the multiplication before you subtract, right? Order of operations. Got to do the multiplication before you subtract. So I'm doing the multiplication, right? That's why I have that multiply sign. And then I subtract 6. Is that confusing? Maybe I should do it this way. Multiply by -1. This is what people mess up on. 100%.
You basically just have to subtract. Wait. So you multiply by
-1,
-1, and
which flips it, and then we take the whole thing and down by 6. Because the negative in front flips the absolute, flips the square root, and then we want to shift everything down by 6.
So you multiply it by whatever number is in front of the
Yep. Yep.
And then-
And then
And then subtract.
add or subtract whatever's at the end.
It's because you're flipping it down, so the y
Yep.
value needs to go the opposite.
Yes, sir.
Yeah. Yeah, you guys are doing great, right? Way to stick with me. This is not easy. This is probably the hardest one. Definitely the hardest probably problem we've done this semester. Like, because like, you know, Descartes was hard because you never saw it before, right? Rational root's hard because you're like, what the heck is this? We've done something like this before, but the order of operations, knowing how to do this, that's what people mess up on. It hurts. Okay. So we have our new values, right? So I like writing it with all the parent numbers, all right, our parent points, do the transformations, and then like rewrite it so I don't have to like just write. So I do the math, and then I don't have to think when I'm graphing. I can just like look at my points. Okay, so -4, -6 is here. -3, -7, 0, -8, and 5, -9. I'll give you a second to make sure you have all these points.
-7
Okay, so
Is it
1
one
times
times-
-1 is -1.
Yeah. it's
-1
minus-
-6 is -7.
Why do you only
-1 -6 is -7.
Okay.
Now this is, because if this wasn't here, like all we're trying to do is flip, right? We're just trying to flip this guy. So we flip it, and then we drop it down by 6. Now the order is important, because if you don't do it in the right order, the graph's not going to be correct. Yeah, this is the hardest thing. This is the hardest thing in the first 2 sections, definitely. What? Ah, yes. That's why I put putting these around to like show it's multiplied versus subtracting. Okay, so let's see if this kind of like matches what we think. So we have our absolute value. Okay, ready to start absolute value left by 4, and then we flip it, and we go down by 6. Right? So that's like the order of how we would transform it. So we take our absolute value, and okay, hold on. It looks like something like this. Left by 4, flip it, and then down by 6. Hey, that's roughly what we're at. Yeah, it kind of has to go order, right? So first, x first goes left by 6, then flipped, and then the whole number is down by 6. Okay. So this is a little more difficult, but we can do it. Think about the domain. Think about our x values. Which x values do we have? Who haven't I heard from today? Eli, I think I heard from you, but what's the domain here?
X is greater than or equal to -4.
Beautiful, beautiful. Right, because -4 is the smallest x value and everything's bigger. What?
So let's go further.
Yeah, that's great. And then the range. Ooh. Who's ready for a challenge? What's the range?
I know. Y is -6 equals greater or equal to -6.
So, okay, so y, -6 is an important number. Are all our values above or below? They all are below, so all our y values are less than or equal to. Ooh, see, this is a different direction than
Got
normal.
the little flip going on us.
Wait, where did you get -6 from? Because that's like the.
-6 is the y value, and all our y values are smaller than that. -6 is our,
Just the first point.
more or less, but you have to be careful with your inequalities. So that's what Ashton was saying before, was it's literally your first point, however much you like shift it. I'm trying to remember if I give you one that like, if our absolute value looks like this, do I give you one that like flips it so it goes this way instead? That's harder. I need to think about it. I mean, this problem is challenging enough because you have to make sure to multiply by -1 before you subtract 6. Oh my gosh. All right, so look at the transformations. This is exactly what we've been talking about. K is the vertical translation, right? If it's positive, it like summarizes. But this is a lot to memorize. Like, why? If you can look at the graph and say, okay, this is my smallest value, everything's above. Like, okay, if it's everything is greater than, like you can write it yourself, right? Just think it through. Okay. And then that's the lesson. So we have like 6 more minutes. We can do more examples if you want, but I feel like we could also be done. Do we want to do one more? Okay, so we're not doing inequalities. But that is it. So we have 6 minutes. We could go over any questions from the practice quiz since your quiz is on Tuesday.
Do we have this class Monday? No.
We don't have class Monday, but quiz is Tuesday, which means you have Monday if you have questions over, like, there's bonus in the math center on Monday. On Wednesday?
Wait, do you have the answers online for your period?
What?
For the practice quiz, do you have the answers
Yeah,
online?
they're online. So let me look at the practice quiz. 6.1 and 6.3. That's it.
Oh, yeah, that's.
Huh? Oh yeah, you can take the hats off. So if you look through the practice quiz, these first 4 problems are just adding, subtracting, dividing, multiplying these 2 functions together. Alright, so the whole first page is roughly like this.
Are there gonna be multiple choice on this?
Let me look.
You're not even doing your.
I'll try to make it some multiple choice on the quiz. I'll try to make it multiple choice. Maybe the domain or range I'll make as multiple choice. But that's where we'll stop for today.